Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So, today, as part of the client side performance metric focus on measuring the performance of a website or web application from the perspective of the client or end user, in this video, we're going to see about the second metrics, which is the page load time. So, we will see what is the page load time and how does it improves the performance of a web application, and we will see the tuning recommendations of the page load time. So first we will see what is a page load time, and before that, this is me, Vasan Shanmugam, and please do subscribe to our Little Star YouTube channel if you have not subscribed yet. Comment your questions and feedback in the comment section, like and share the video with your friends. So first let's see what is a page load time. So here I have three websites with the page load time. So how first we will see how to see the page load time. So to see the page load time, press F12 and the developers tool will open, and here you can see the page load time here. So the top page, which is the main page, is where we will have to see the page load time, and here it shows 630 milliseconds to load the amazon.co.uk, and then when it comes to Argos it shows 174 milliseconds, which is very faster or very quick when compared to the Amazon. And then when it comes to Currys, it is just 337 milliseconds for the page load time. So let's see what is a page load time now. So a page load time, in very simple terms, it represents the time it takes for a web page to appear and become interactive after we click on the link or enter a URL in the browser. So that is the page load time. So in context of the client side performance testing, the page load time refers to the time it takes for a web page or application to fully load and become usable by the user. So it has to be become usable by the user, and that is what we call as page load time. And this measures the duration from the moment. So here we can see, so it shows from the moment the user initiates the page load, typically by entering the URL or by clicking a link. So if I just refresh it again, so here you can see, so by the link or when the page is fully rendered and all its resources such as the HTML, the CSS, the JavaScript, the images. So let me go to the top. So here you can see, so this is the page load time here, and so everything is should be downloaded, processed and displayed. So that is what we call it as page load time. So when we correlate this with the web page or application, so when we visit a website, we use the application. So the browser sends the request to the server. So now we are sending a request to the currys.co.uk server, which hosts the website of the application. So the server responds back with the necessary files. So here we can see main.js, we see product tile.js. So whatever files that are required, so it send back, the server sends back all the necessary files and resources which are needed to display the page, such as the HTML, the CSS, the JavaScript, the images, and everything which is part of the application. So here if I open through the performance analyzer, so here we can see every component which are required for this page. So here you can see we have 135 scripts, we have 45 images, and we have 34 XML HTTP requests. We need 14 CSS, we need 8 iframes. So same for the Argos as well. So here we can see the entire set of requests that are needed for the page to get loaded. So what happens when we do the page loading, or when the page loads? So during the page load, there are several steps that happen. So out of that, the very first step is the DNS lookup. So the browser determines the IP address associated with the domain name of the website by performing a DNS lookup. So once the DNS lookup is done, it next moves the connection establishment. So the browser establishes a connection with the server over the internet using the IP address obtained in the previous step, which is in the DNS lookup. So once the DNS lookup is done, the browser then gets the DNS, and then it tries to establish a connection with the previous step, which is the DNS. And then once we establish the connection successfully, we then The browser then sends a HTTP request to the server asking for the specific resources needed to load the page, and the server then processes the request and sends back the requested resources in the form of a HTTPS or HTTP response. So that's the third step. And then finally, the last one, which is the resource download and rendering, where the browser starts downloading the resources such as the HTML, the CSS, the JavaScript, the images, and others by specifying, which are specified in the response. So once downloaded, the browser parses and interprets these resources to render the page on the screen. So how does this page load time is measured? So here we can see the page load time is measured, which is 174 for Argos and 365 for Currys and 630 for MS. So how does this page load time is measured? So this is measured from the moment the browser sends the initial request. That is the moment we click enter. So from this moment to the moment the page finishes rendering. So now the page has finished its rendering. It's still rendering. So now the page has finished. So here we can see some requests are pending. So still I think it's like loading. It's keep on rendering and becomes fully usable. So that is what. So here now we can see it shows 700 milliseconds. So by the time it's become fully usable, so that is what we call as page load time, and this includes the time spent on network communications, the server processing and downloading resources and rendering the content. So what is the goal of optimizing? So why we should optimize it? So the goal of optimizing the page load time is to ensure that the web pages, so these web pages and the applications should load quickly, and it should provide a smooth user experience. And faster page load times lead to better user satisfaction, which we all know, and it increase the engagement with the user, and it in fact potentially improve the conversion rates, which is the user will start keep on buying the items every time when he wants to buy something in the website. So basically it has to be very quick. So now let's see what are the tuning recommendations. So now we found out that the page loading time is very less, and what are all the ways we can improve the performance, or how can a performance engineer gives tuning recommendations to the developer. So the first one is optimizing and minimizing the resources. So the first way is to compress and minimize the HTML. So compress the HTML, the CSS, the JavaScript files to reduce their size, and by combining multiple CSS and JavaScript files to a fewer files to minimize the number of requests. And then by utilizing the minification techniques. By minification techniques, we can remove unnecessary characters and spaces from the code. And then by optimizing and compressing images. So by optimizing and compressing images to reduce their file size without compromising the quality. And then finally, by leveraging the browser caching. So by doing all these techniques, so in fact, we can leverage the browser caching of static resources on the client's browser. So by doing all these techniques, we can optimize and minimize the resources. And this, in fact, is the very first and most followed technique to improve the performance. And this can be easily convey to the developer, and he can start doing this. And when it comes to the next one, which is the reducing of server response time, so how can we do this? So this can be done first by optimizing the server side code and DB queries. So this can be done to reduce the server response time, and by minimizing this, it the time it takes to generate and deliver the server response. And then by implementing caching mechanism to cache frequently accessed data or database query results, and then utilizing the CDN, which is the content delivery networks, to deliver static resources from servers located closer to the user. So these are the three techniques which we can use to reduce the server response time. And then when it comes to prioritizing above the fold content, so by loading critical above the fold content first to ensure that users see important content without any delays. So by doing this, the user will not feel that he is lost or he is missed out and he can wait for some time for the other resources to get loaded. And the inline critical CSS and by loading non-critical CSS asynchronously to prevent render blocking. And then the fourth technique, which is to implement the asynchronous loading. So by loading the JavaScript files asynchronously to prevent them from blocking the rendering of the page, and by using the async or defer attributes when including external JavaScript files, because most of the times the developer must use, or when he uses any external JavaScript file, so he can include the async or defer attribute so that the user must not need to wait for a long time, or those attributes or those JavaScript files can be loading on its own pace. So this can be done to implementing the asynchronous loading technique. And by loading non-critical resources, for example, you have a lot of social media widgets, or you have third-party scripts, or any other attributes which can be asynchronously loaded to avoid the slowing down of the main page. So these tuning recommendations has to be given to the developer to implement the asynchronous loading, so that the page will load quick and the response time will be very quicker, and the page load time will be very less. And then when it comes to optimizing of rendering, so this can be done by reducing the number of DOM elements and by minimizing the unnecessary DOM manipulations, and by using efficient CSS selectors and styles to optimize the rendering performance. And then we can avoid excessive nesting. So this is one of the main recommendation which has to be given to the developer. So by avoiding excessive nesting of HTML elements, so this can improve the performance by optimizing the rendering. And then when it comes to lazy load content, so let me just remove this first. So when it comes to lazy load content, by implementing lazy loading for images or for videos or for any other non-critical content to defer their loading until they are needed. And in fact, this can improve the page load time and the lazy load content as the user scrolls down the page to prioritize the initial load. So finally, when it comes to monitoring and analyzing the performance, as we have already discussed in many of our videos, so by using the performance monitoring tools to measure and analyze the page load time, and by identifying the bottlenecks and areas for improvement, and by conducting regular performance testing to track the impact of optimizations and ensuring the ongoing environment. And these tuning recommendations will vary depending on the technologies and frameworks that are used in our web applications. So it's crucial to analyze and address the performance bottlenecks specific to the application's architecture and infrastructure. So all these can be used in our tuning recommendations, but most of the times not every recommendations will be suitable for our application, and but at least one of them will be definitely suitable. So it all depends on the performance engineer, so he has to analyze all the pages. So that's why we have a lot of extensions and tools where we can do all the investigations, and at the end the developer or the performance tester should come up with a complete clear draft of what the developer has to tune so that the application will have a better performance. So with that, we come to an end. Until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and Little Slav.